Welcome back. So today we will do what is known as a autotransformer, and in autotransformer is essentially a single phase transformer. Autotransformer is essentially a single phase transformer connected in connected in which the primary and secondary windings are connected electrically. For example, here I have connected the primary and secondary windings in series in such a way that finally at these terminals I am having a voltage boost. So what I have essentially done is taken this end of it and connected it here. So therefore when you trace the currents, you will get voltage. This gets V1, to which you add this V2 and you get a V1 plus V2, which is available to the load which is connected on the secondary secondary side. So this is an auto transformer which is doing a step up function. The reason why we do such a kind of thing is that we want to increase the rating of the of our net device. You will see that as I go forward. So what happens here is voltage, which is now the load is actually connected. The load is connected to a voltage of V1 plus V2. And now let's say that this is the secondary winding, this is the primary winding. The secondary winding is rated to carry current I2. So load is such a correct value of load has been put so that it is delivering the current I2 to it. Then the MVA, or the apparent power, which is delivered to this load is how much? V1 plus V2 into I2. And so we can simplify this as V1 by V2 is equal to N1 by N2. So therefore for V1 I am going to write N1 by N2 times of V2 plus V2 times of I2, which is same as 1 plus N1 by N2 times V2 I2, which is nothing but the rating of the device of each of the windings, which is S. So therefore the power output, which is the output or the power which is coming out of this transformer, is 1 plus N1 by N2 into S. So because it is 1 plus something, which is positive, you clearly see that there is a boost in the output of the transformer, and that boost factor is 1 plus N1 by N2. Now let's see how it is happening. So if I am drawing the current I2 out from the secondary side of the transformer, then the MMF balance principle says that the I1 current should flow into the primary winding. So the I1 current is flowing like this into the primary in the dotted terminal, and from the secondary I2 is coming out, and therefore this has a magnetizing effect, this has the demagnetizing effect, and the MMF balance is held. So now there is a source connected here. How much is the source going to pump? How much current is the source going to push into? You apply the KCL at this point. I2 going up, I1 going down. The sum which is coming here is I1 plus I2. So therefore, if you look at the power, which is apparent power, which is supplied from the primary, rated voltage V1 is applied, and the current which is pushed in is I1 plus I2. Now I1 plus I2 is in inverse proportion to the turns ratio. So I1 by I2 is equal to N2 by N1. Let's use that to simplify this equation. So this will become V1 into I1 plus N1 I1 by N2, follows from the MMF balance principle, which is equal to V1 I1 into 1 plus N1 by N2, which is again same as 1 plus N1 by N2 times, again V1 I1 is the V1 I1 is the rating of each of the windings, in fact the rating of the single phase transformer. But as expected, if the output from the transformer was 1 plus N1 by N2 volt amperes, then the input out to the transformer is also going to be 1 plus N1 by N2 into S volt ampere. So it's very clearly still a nice transformer kind of the action. There is nothing which has surprised us except for the fact that we have got much more out of this transformer in terms of volt amperes than was the individual rating of each of the windings. Why has this happened? This has happened because in a normal single phase transformer, the power transfers from primary to secondary only through the mutual coupling which is there which is the magnetic field coupling. But in the autotransformer, the power which is transferred from primary to secondary is not just through the magnetic coupling, but it is also happening because of the electrical coupling which is taking place. And in fact, what gets done through the magnetic coupling is still the same. It's N1 I1 here and I mean V1 N1 here and it's V2 N2 here, but the electrical coupling causes the remaining power to flow from the primary to the secondary side. This is an advantage. See, if this is an advantage, you are able to get in the same cost a much higher. You can get a much higher rating of the auto transformer. And what happens? What happens to the losses? Because both the windings are used to their rating only. The core loss, for example, will be the same. The flux level is the same in the winding, so the core loss is going to be the same. So the no load losses are going to be the same. Again, both the windings carry their own rated current, so the copper losses are also going to be the same. So that means that the losses don't change, but the rating of the transformer goes up. It also means that the efficiency of the transformer goes up. There is only one cost which we had to pay for it, remember, and that is that in these two, in the normal single phase transformer, the two windings are electrically isolated. So you can have a 1:1 transformer, for example, just to create electrical isolation between the primary and the secondary circuit without. The only coupling is that of a magnetic coupling which is there. But in case of a auto transformer, you have a electrical coupling between the primary and the secondary. So this could have some safety implications for you. So let's okay, one more small point what I want to say is that the coupling the leakage impedance of an auto transformer will be usually less because the two windings will be more closely knit or coupled in case of during the construction of an auto transformer. What I mean to say is that, for example, if I am making a auto transformer, let's say I make this as one winding, then I let me duplicate this and let me make a smaller winding here, and what I am going to do is I am going to just connect this as one primary winding and I'll continue here, that's the secondary winding, and take this out here. So this will become, say, V1, and the way I had drawn it, I will connect this to this here, and here I will connect the load with V1 plus V2 and giving the current I2. So you can see that since I can more tightly wind the winding here, I'll get a much better coupling on the much better magnetic coupling, which means lower leakage impedance with the auto transformer. So I have already, this is the basic idea, very simple. To conclude, rating of a auto transformer is 1 plus N1 by N2 times the single phase transformer, cost saving at a slight expense of improving the insulation level of the secondary winding. Yeah, this is a point I need to mention. Since this voltage here at the output is now coming as V1 plus V2, this secondary winding should have higher voltage, higher insulation than what you would have here, which is just a insulation adequate for V2. But here, this part of the secondary winding would need a insulation, which is for V1 plus V2. So at the construction stage itself, this will have to be taken care of. Then the losses remain the same, so efficiency is much higher, leakage reactance is reduced, and electrical coupling between the primary and secondary is the only is the only concern, and is also the cause for the boost in the rating of the transformer. Now let's do a small example to illustrate these points. So I have a 1000 kVA 50 Hz single phase transformer uh, with a voltage rating of 800 to 800 is to 200 volts. So the primary I'll take it at is 800, secondary I'll take it at 200. Can we reconnect it to serve a 1 kV load? 1 kV is 1000 volts. So yes, just connect the primary and secondary in series. So you will get 800 plus 200, which is equal to 1000 volts. If yes, how many volt amperes can it deliver? So what we will do is what we will do now is that we connect V1 is 800 volts, V2 let's take it as 200 volts. Then we get primary being V1 and secondary being V2. We get N1 by N2 ratio to be equal to 4. So therefore we saw that the S rating of the auto transformer is going to be equal to 1 plus N1 by N2 times the S of the single phase transformer. So therefore this is 1 plus 4 times 1000 kVA, which is same as 5000 kVA, or effectively 5 million volt ampere. So you have got a 5 times boost here. Now suppose instead, let us say that we had taken primary to be 200 volts and secondary to be 800 volts. It's given to you as 800 to 200, so you should actually take primary as 800 and secondary as 200. But for the sake of discussion, suppose we had done like this. That is to say, the NP by NS would have turned out to be 200 by 800, in which case you would have got it as 1 by 4. So now you see that in such a configuration also, you will still get 1 kV at the output, but the power rating is only going to increase by a factor of 1.25, and you will just get 1250 volt amperes. So the point which I am trying to make is, if you had a primary source of 800 volts, you would have got a significant amount of power boost with this auto transformer interconnection. But if your primary voltage source was only 200 volts, then you don't get that much boost with the auto transformer, and that's understandable. Why is that understandable? Because see, the current which is being pushed here in the primary of here is always I1 plus I2, so that current is fixed. Once you had 800 volts connected here, the other time you had only 200 volts connected here. So in the first case, you will push in much more power. In the second case, you will push in much less power. So there is not a magic device, but a very interesting device which can cut down on the cost space and still achieve the functions of a power transformer. So it's quite used in the utilities, do use it for this very reason. Let's stop this video here. Thank you.